Welcome to Lesson 3.5, Linear Equations and Problem Solving. So again, we know linear equations can be represented using a variable and can also be represented if we graph them by a line. So we're going to look at problem solving word scenarios that can be set up with verbal models and then the algebraic model of a linear equation to arrive at our solution. Now, I'm going to come back to example 1 because, as you can tell, it involves fractions, which I know is everyone's favorite. So we'll start with example 2, a scenario that does not involve fractions. So in example 2, we have the word scenario that states at East High School, 579 students take Spanish. This number has been increasing, so the increasing part I want to keep in mind, increasing at a rate of about 30 students per year. The number of students taking French is 217 and has been decreasing at a rate of about 2 students per year. At these rates, when will there be 3 times as many students taking Spanish as taking French? And apologies for a couple typos in there. That should say rate of and as many students. So let's look at our scenario to begin with. 579 students in Spanish, increasing at a rate of 30 students per year. So in that case, if I was going to do a verbal model just for Spanish, it would be the number of people in Spanish now, plus, because it's a rate of increase, our rate of increase multiplied by the number of years. And what we're trying to figure out is when will there be 3 times as many students taking Spanish as French? So on the French side, we have 217 students, decreasing at a rate of 2 students per year. So in that case, the number in French now minus, because it's a decrease, the rate of decrease multiplied by the number of years. And we want to know when these two will be equal, but there being 3 times the number of Spanish students as French. So 3 times the French, when will that equal the overall Spanish? So I can convert that verbal model into my algebraic model. So the number in Spanish now, 579 students, plus the rate of increase 30 times the number of years x. So 579 plus 30x. We're setting that equal to the 3 times, and then the 217 in parentheses, number in French now, minus the 2, that the rate of decrease, times the number of years x. So I used x for my variable for number of years. So then the parentheses are around the number in French now minus the rate of decrease, because it will be 3 times the result based on that change over time. So what we need to start with on the right is the distributive property to distribute that 3. So we'd have 3 multiplied by the 217, or 651, and then the 3 multiplied by the minus 2x, or negative 2x. So it'd be 651 minus 6x. So 579 plus 30x equals 651 minus 6x. Then we want to get our variable to one side, so add 6x to each side. 579 plus 36x equals 651. Subtract 579 from each side of the equals. And then we have 36x equals 72. Divide both sides by 36, and x would equal 2, telling me in 2 years' time, there will be 3 times as many students in Spanish as there are in French. Now, we're going to look at example 3 and then go back to example 1. Ignore this down in the bottom left. That's for a different class. So, example 3. A gazelle can run 73 feet per second for several minutes. A cheetah can run faster. The cheetah can run 88 feet per second, but only sustain the top speed for about 20 seconds before it's worn out. So the gazelle can run the 73 feet per second for several minutes, but the cheetah can run at 88 feet per second, but only for about a 20-second burst. How far away from the cheetah does the gazelle need to stay for it to be safe? So what would be the safe distance for the gazelle to start away from the cheetah so that that cheetah cannot close down that space within that 20 seconds of both animals running? So my verbal model would be the distance the gazelle runs in 20 seconds. So we're trying to use 20 seconds because we know that's how fast or how long the cheetah can run at its fastest. So the distance our gazelle will cover in 20 seconds plus that distance from the cheetah would equal the distance that the cheetah runs in 20 seconds. So the unknown part is how far that gazelle has to be from the cheetah. So the gazelle's distance covered would be 73 feet multiplied by 20 seconds plus x, our distance. And then on the right, the distance the cheetah runs times its rate, so the 88 feet per second times the 20 seconds for the cheetah. So then we end up with 1460, 73 times 20, 1460 plus x equals 1760. Subtract 1460 from each side, and that tells us that starting distance for the cheetah to be safe, or not the cheetah, the gazelle to be safe from the cheetah would have to be at least 300 feet. Because in that 20 seconds, that distance between the two of 300 feet would be closed down. So how far do they have to be? 300 feet. Now let's go back and look at example 1. So in example 1, it says a page of your school yearbook is 8.5 inches by 11 inches. So typically with yearbook pages, they go, the longer way is the height, and then the shorter distance is the width. So they're longer in their height. So it's 8.5 wide by 11 inches tall, even though I drew it so it looks wider here. That's just so I could draw it with spacing. It's actually 11 inches tall, so you could draw yours taller if you want, by 8.5 inches wide. And then let's look at the rest of this scenario. The left margin is 3/4 of an inch. So the left margin, so the margin is this blank space on a page. So our left margin is 3/4 of an inch. So I know over here, I have a margin of 3/4 of an inch. To the right of the pictures is 2 7/8 inches. So we have a space to the right of the pictures of 2 7/8 inches. In between the pictures, there's 3/16 of an inch. How wide can each picture be to fit 3 across the width of the page? So we have our dimensions of the page, 8.5 wide by 11 tall, a margin of 3/4 of an inch, then the space on the right, that's 2 7/8 inches, and in between each picture, we have 3/16 of an inch. So we want to know how wide each picture can be, assuming they're going to be the same width. So drawing my diagram, I have my 3/4 margin, my 2 7/8 margin, my three pictures with their unknown widths. So I went with the letter W for width, and then the 3/16 of an inch in between each picture. So my verbal model would be the left margin plus the space on the right plus 2 times the space in between the pictures plus 3 times the width of the picture would all add up to equal my overall page width. So 3/4 plus 2 7/8 plus 2 times 3/16 plus 3 times our variable W would equal the 8.5 inches. So now I know what I can do is start to simplify the left. 2 times 3/16 is the same as 2/1, so 2 times 3 on top is 6. So I'm just going to leave that as 6/16 for now. I'm not going to worry about simplifying. So then I have 3/4 plus 2 7/8 plus 6/16 plus 3W equals 8.5. So what I decided to do on the left was create the common denominator as 16 so that I could combine all my fractions. So 3/4 becomes 12/16. To convert the bottom, 4 times 4 is 16. So the top, 3 times 4 is 12. Then the 2 7/8, converting the mixed number, you just leave the whole number in front alone. So the 2 is still a 2. And the 7/8 becomes 14/16. 8 times 2 on bottom, 7 times 2 on top. And then the 6/16 just remains 6/16. So then if I add my 12/16, 2 14/16, and 6/16, I get 2 32/16, which is 2 32/16, plus 3W is 8.5. Well, 2 32/16 is, 32 divided by 16 is 2. So 2 wholes added to the 2 out front is 4. So really what I have is 4 plus 3W equals 8.5. Subtract the 4 from each side. So 3W equals 4.5. Divide both sides by the 3, and that tells us W, the width of each picture, can be 1.5 inches. So as you work through these problems, what you want to try to do is underline or highlight important information in the problems, draw an image if you can to help you understand it, write out a verbal model before converting it to your algebraic setup, and then at the end, just simply think, is your answer reasonable? Does it make sense? And if not, go back through the word problem and see if you missed any key vocabulary or key terms that could help you out. So also with this video lesson, I'll post a few extra examples that you'll see in Google Classroom of these types of problems.